Good morning, everybody. Happy Sunday. How are you? I hope you're doing well in your part of the world. I hope your families are well. And also, I hope that you're ready to come and learn and have a good time and make some more progress into our continued study of the Introduction to Statistical Learning book. We've been having some really great sessions. I had a really good time during last week's session because there was a lot of interactivity and a lot of questions. So really happy to see that. And I think we're going to have a little bit more of that today. I think today is a very special chapter. For today, I do want to cover chapter 5. We've been making great progress. The whole book is only 10 chapters and we're already on chapter 5. So we should all feel pretty good about that progress that we made. And I already see a couple people in the chat that have been consistently coming. So I'm really glad that you guys are getting something out of this. And I'm sure that there's people also that are watching the replays, which is also fantastic. So I think we should all just kind of take a little bit of a step back and realize that we're making some really good progress. This is our third session. We're already on chapter 5. The entire plan is to have 8 sessions. So we're almost at the halfway point of the sessions overall. So really, we've been doing so well. So thank you so much for making this a positive experience for both me and for you. But today is going to be chapter 5. We're going to learn about resampling. We're going to learn some terms and some definitions. To me, well, let me put it this way. I've gotten questions in the past in the chat or messages or whatnot or comments where people say, well, where can I learn the vocabulary of data science or can you teach me the vocabulary of being a data scientist? Because sometimes I say that in some of my content where I tell you that when you've done the work, when you've really put in the time to be a data scientist, it comes out in how you carry yourself, the vocabulary you use, the terms, the way you explain things. There's no shortcut to learning that. I'm not going to sit here and type like a list of words that, as a cheat sheet that people can use. That's not my style at all. But I think that today, with chapters like resampling and some of the methods we're going to look at, this is kind of where your vocabulary and your approach to data science kind of takes a step up, right? Here's when we start talking a little bit beyond algorithms and like, I don't want to say the basics of data science, but I think that in this chapter, you really kind of take a step up in your thinking and in your overall approach. I really didn't understand the intricacies of data science until I really understood some of the resampling concepts that we're going to cover today. What do you mean an algorithm learns it? What do you mean it trains itself? What? Like, what are you talking about? Like, it started to make sense for me after reading a chapter like today. So I'm super excited. I put these materials together like, the night before or a day before because, sometimes I need a refresher. So it's been fun to go through some of these chapters to kind of bring all that to you. And as I've done before, I'm going to break out the things that I think are the most important. I curate the chapters for you because obviously I love the authors. I love this book, but I've seen, I come from the real world perspective. So I've seen some of these things definitely used and some of these things less used, right? So I'm going to give you some of that today also because, it's always helpful to have like that real world check. So I see people already joining us on YouTube and already joining us on Instagram. Bala R, can you please start? That's what we're doing now, my friend. Pump the brakes here. Pump the brakes, okay? Calm down. Everybody calm down. We're going to have a great session. I think I might need more moderation on Instagram for things like that. But yeah, I see people in the chat already. If you're on Instagram, I love that. Instagram will always be my favorite platform. However, for classes like today, it might be a little bit better for you to view it on YouTube. That way you get a widescreen format. You can see the different things that I'm sharing on the screen as far as the different, kind of like a classroom view that I have. So please consider also joining us on Instagram. On YouTube, because I think the format's just a little bit more convenient there. Or you can always, join us right now on Instagram and then watch the replay later on YouTube. So I want to acknowledge the chat because we have so many people already in there. If you are joining us, feel free to introduce yourself or just say hello. Or maybe you just want to hang back and just, enjoy the materials. That's okay too. But I want to give it just a couple of minutes here so that we can kind of see where everybody's at and just say hello to everybody. All right, so Joseph Hernandez, my good friend Joseph, a huge participant in our chats and in our Discord. So if you'd like to join the Discord, please do so. We've been having some great conversations on there. It's a great way to keep in contact with everybody, kind of away from the streams or away from more static content. If you need a little bit more real-time feedback, the Discord is great for that. So Joseph, glad to see you here. And Joseph is also helping with our moderation on the YouTube side. Hamad, good to see you. Another great participant on Discord from Haripur, Pakistan. Welcome, Hamad. Good to see you. Rex, our good man in New York City. Yes, I've heard that it's rainy in New York City. I still have plenty of friends there. I heard there was a big rainstorm yesterday. So Rex is also helping us with the moderation on the Twitch side. We have a growing presence on Twitch. I think we're going to get a lot more participants on Twitch. So Rex is going to be helping us with that. So thank you to Rex, Joseph, and Patrick Stefanik for helping us with the moderation. If you want to give them a shout out. Rohan, my good friend from Bizag, India. Nice to see you. Glad to see that you're still coming back to the classes. Thank you so much. Explore the beauty of nature. Great to be here today. My good friend, Explore the Beauty. Explore the Beauty is one of the folks that has been here since the first session. So thank you so much for your continued study. I hope this is helping you. I know you've been there from the first session and you stayed for the whole session. So that's not easy because sometimes we go 2 hours plus. So thanks a lot for that. Good to see you, my friend. Hope you're well. Samir Sen. Samir, good to see you again. I haven't seen you in a little bit. I know you've been a great supporter in the past. I hope you're well. Hey, Dennis, checking in from Lalitpur, Nepal. Hoping you're doing great. I'm glad today I'll be here the whole session. Wonderful. We'll be glad to interact throughout the session. Wow, 2 wonderful things. Thanks so much, Samir. And we're going to need the interaction. I'm going to be asking a lot of questions today, okay? So I'm going to be asking a lot of questions and you guys are welcome to reply. I know some people are maybe a little hesitant to reply. That's okay if you just want to hang back. But sometimes it just helps to see where each other's thinking is at, right? Part of the scientific process is understanding and being able to appreciate other people's perspectives. So we're going to do some of that today, okay? So Rex saying Twitch is here. Yep, thanks so much, Rex. Appreciate you doing the moderation there. I am 541 Vikral. Hi, sir. Hey, nice to see you. Let us know where you're from, and I see that you're on Instagram. Feel free to switch over to YouTube. Just might be a little bit more of a convenient format. Michael, happy Sunday, everyone. Michael here from Lagos, Nigeria. Nice, Michael. Good to see you, my friend. I'm pretty sure you've attended the classes before, so glad you're well. Good to see you. Alan Valdez. All right, boss, I'm in. First time caller, long time watcher. All right, Alan, thanks so much. Thanks for stepping up and saying hello. Really appreciate you doing that. Good to see you. And, maybe you'll feel comfortable participating in some of the back and forth and some of the questions, because I do throw out questions. So I appreciate that you're here. Joseph is very conveniently putting out a link to the Discord. If you guys want to join us on Discord, we've been having some really good conversations. Please go ahead and join us. And again, it's a good way to keep the conversation going beyond when I'm online or other things like that. Plus, I think it's really cool to see the community helping each other. We have some really smart people in there, so really, really glad to see that interaction. Amina Blue says, hello, Dennis. I have a few questions regarding the previous lies, if we could go over them. Thanks. Yeah, I think you might have sent me a question overnight, and I mentioned that the Discord would be great for that. But yeah, if you want to, hang out, and I will make time towards the closing end of today's session, to address some of those questions, or people have, well, undoubtedly questions will come up during today's stream, right? But let's hold those to the end if you don't mind. But I appreciate that that you came back, and I'll be happy to address them, okay? Stippus says hello. Stippus, nice to see you too. I think you're one of our more recent joiners on Twitch. So glad to see you there. I'm slowly growing on Twitch. I finally got to the double digits on Twitch. It's been a long climb with the Twitch platform. I guess it's because it's so oriented at gaming. But, slowly, guys, we're gaining an audience on Twitch. So good to see that you're checking in. And by the way, again, if you're on Instagram, maybe you don't have a YouTube account. Most people do, but maybe you have a Twitch account. And Twitch also provides a good widescreen format for you to view all the classroom material. Amine says, watching from Morocco, it's 4 p.m. actually. Yeah, I'm sure it's a little bit later in the day in Morocco and in a lot of countries. For me, it's early morning. For me, it's 8 a.m. and I love streaming at this hour. But yeah, it's the most convenient hour I could find for most regions. But thanks for joining from Morocco. Alan Valdez says that Discord link has expired. By the way. Yeah, Alan, thanks for that. We do need to update the Discord link. Joseph, there is a newer one available. I just don't think I've sent it to you, but we'll take care of that, Alan. We'll take care of that, a little later today, or feel free to send me a DM and I'll get it to you. But yes, you are right. I think there is a more current link, and which I'm really disappointed in, because the initial one I created said it was non-expiring. I set it for non-expiring, but then for some reason at 60 people, it just stopped accepting people. So I don't know what happened. But yeah. Al Kathiri says hi from Oman. Nice. I don't think we've had many viewers from Oman, so nice to see you. I don't recognize your name, so I think you might be the first time joining us on the Sunday session, so welcome. I see that you're on Instagram. Feel free to switch over to YouTube if you're comfortable. That way you can kind of see the classroom view and all that, okay? Ahmad says, congrats on 2,000 subscribers on YouTube in advance. I appreciate that, Hamad. It's gonna be a little while still for 2,000, but thank you for that. I just crossed 1,000. Working my way up, right? You just got to keep at it. But you know what? I'm just having fun with this because I'm passionate about data science. Hopefully, I'm just letting all of the other stuff kind of follow behind, right? I'm just going to keep on doing the best I can to bring you my experience from, my time in the trenches in data science, and hopefully good things will come, right? That's all we can do. Michael says Discord link not working. Yeah, you're right, Michael. We'll get that fixed. Okay, looks like Joseph has published a new one, guys. So let's go ahead. So maybe you guys can try that one. If not, Joseph, I'll send you the latest one. I can't remember where I posted it. I should have sent it to you via private message. But yeah, but Joseph looks like he's generated a new one. Hey, Adela, let's try to not spam the chat, please. Okay. Well, first of all, today we're really not taking questions. I'm willing to take questions at the end because I'd rather get to the class materials, because I know that's why some people show up. But please, let's not try to spam the chat. If you post your message and it appears on your end, I guarantee you it's appeared on my end too. It just takes me a while to get to the questions. But please, let's keep it professional and not repeat the questions. Okay, so what I want to do is I want to cover the class materials, and then we'll do questions at the end, because I'm almost positive that today's session is going to bring up more questions, right? So totally get it that some parts of today are going to be maybe just a little bit challenging, but I think that it's going to be fun. And today might be one of those sessions where you kind of have to, take in the information, walk away from it, and then things will start to light up. But like I said, for me, chapter 5 was a huge aha moment in my own, education cycle. So interesting topics says, can you tell me what is going on in brief? Just join now. Well, thank you so much for joining. I appreciate that you're spending some time with us. Essentially, we are going through Introduction to Statistical Learning, which is a great book for data science, for professional data science. Today is chapter 5. You are welcome to look at the previous replays that are stored on my YouTube channel for the previous chapters. But today is chapter 5. So let's get into it, because I know people showed up for the class, so let's do it. All right. Chapter 5 is resampling methods. And by the way, guys, if you need me to blow up anything on the screen because it's not big enough on your screen, let me know, okay? And let me adjust a couple things here to make it even bigger. Get rid of that, and we're going to get rid of, oops, nope, got that wrong. Okay, that makes it slightly bigger. Okay, chapter 5, resampling methods. All right, what is resampling? Let's start right there. We're going to start with audience interaction right away. If you're comfortable, because I understand this is taking a step up, right? But if you're comfortable, give me your elevator pitch on what is resampling methods. Well, what are we referring to when we're talking about resampling methods? You can give me examples of resampling methods. You can give me a definition, whatever you guys think, whatever pops into your mind when you're thinking about resampling methods. I'll give you guys, a minute or so there to think about it. Amrapali, hello, welcome back. I'm pretty sure you've attended our sessions before, so good to see you again. So we're just getting started, and the current question for the chat is, what is resampling methods? Just tell me what you think it is. No, don't give me a fancy answer. Just give me your elevator pitch, or give me examples of what it is, or something that you think is associated with it. What do you guys think? Okay, so Hamad is stepping up, putting up our first answer. Resampling is drawing samples from training data to fit in our model. Okay. If you want, you can just agree with Hamad, right? You can say, yep, I agree with Hamad. Or, okay, so Alan says, I agree with what Hamad said. Praveen, good to see you again. Welcome back. Yep, but Alan says, I agree with Hamad. Anybody else? All right. David Warder, welcome. I don't think I've seen you before, so welcome to the chat. David Warder says, using individual data points more than once in planned methods to increase your statistical power. Okay. David, I like your take on this. You came at it from another angle. We're gonna come back to what David said. I like it. Explore the Beauty says, this is a technique to modify the training data to improve the model's performance and increase overall accuracy. All right. Bright Eggbee, and I don't think I've seen you before, so welcome. From my understanding, a method to balance data set with unbalanced labels. All right. All right, Amram Pali says, picking different combinations of samples from the same pool of a data set. All right. A resampling method is a way to understand data better by taking multiple smaller samples from a set of data. All right. Samir says, creating new samples from existing data sets. Okay. All right, anybody else? These are great. These are all great answers, by the way. Anybody else for resampling? Good answers, though, guys. Great participation. All right, so I'm going to give you a couple different definitions that the authors give. These are two items that I've pulled from the book. These are directly in the book, and in fact, I think that they're in the first section, right? So this is what they're offering. What do you guys think? Exploring the Beauty adds examples include bootstrapping and cross-validation. Okay, I love that you jumped to the examples. We're gonna get to those, but yeah, I love the fact that you pointed those out. So what do you guys think of these definitions with the authors? Do they kind of fit what the previous answers that we saw? Because it's nice to see that most of you did have an opinion on what resampling is, right? Some people would shy away and say, oh, I'd rather not say, but you guys did a great job with coming up with them. But what do you guys think? What do you guys think? I mean, I think that, personally, I think there's a pretty good parallel here with what the authors are saying versus what we saw in the chat. So you know what? Let's make this a quick poll. Give me a 1 if you agree that that the chat correctly identified what the author said, or give me a 0 if you think that there might be some other gaps or if you see it a different way. But generally speaking, I think that it deserves a 1, but give me a 1 or a 0 in the chat. All right, so Rex is voting with the 1. He thinks that we're pretty closely aligned with the authors. What do you guys think? Anybody else? All right, there's another couple 1s. Okay, yeah. So I think that we're in general alignment with what the authors are writing. Yeah. Okay. I'm seeing a lot of 1s in the chat, and I think you're right. I think that we are understanding the what of resampling. Like, what is it, right? But here's another question. Another similar question. But I want you to think about this way though, right? Why does resampling exist? I think we gave ourselves a pretty good definition of the what, right? What is resampling? But why does it exist? Like, why would you need to do this? Like, why is resampling even a thing? So give me your elevator pitch on that. I mean, the authors dedicated a whole chapter to resampling, right? So it must be important in some way. But I want to understand the why. Because remember, we're professional data scientists, right? So we always kind of want to seek out the purpose for what we're doing, right? Because otherwise you're just a monkey, at a keyboard, right? But you want to understand the why of, why are we pursuing resampling? Okay. Okay, so Deb is stepping up and saying if sample does not represent the population correctly. Rex says to mitigate issues with small size data sets. Because data sets are usually big. So this is Samir, by the way, because data sets are usually big. So in order to simplify the decision-making process. Joseph says we would like our sample to be more representative of our population, perhaps. Okay. It is sometimes expensive to collect large samples of data, so resampling help us. Okay. David says data is finite. You can't always go out and efficiently get more data, so you have to be efficient with what you have available. All right. Hamad says because of limited data. Okay, guys, so let's put a stop there. Because I'm not sure if I'm on board with the answers so far, right? Because at this point, there seems to be a little bit more of an emphasis on the sampling side, right? Because that's kind of like where these answers are headed, right? Like, I appreciate the participation, guys, an A for effort, but let's kind of rework ourselves back, right? Because I really enjoyed Explore the Beauty's mention of bootstrapping and cross-validation. Now, I know a lot of you have read the chapter ahead of time, or maybe you're already familiar with the book, or a lot of you can give me a definition for what cross-validation is, right? Cross-validation isn't because of some of the items that you guys are mentioning here. It's not because of limited data or because, the data is too large, so we want to maximize the efficiency. That's not really what cross-validation and bootstrapping is for, right? So let's kind of hammer that conversation back into it. Hamad says also model validation and estimating accuracy of parameters. Okay. See, so now I think that we're kind of getting ourselves back on the right track. So let's try to build on Hamad's statement there, because I think that's a little bit closer to where we want to be. Yassine says, so that our model doesn't just memorize the data and be able to detect patterns and generalize. Okay. Okay. Michael says to eliminate bias, I guess. Okay. Michael, I think that's a creative answer. I think you might be on the right track there. Rex says to evaluate model performance. Okay. Yeah. You know, Rex is the first person to mention model performance, right? And that's kind of a key thing, right? Hamad says model validation. We use cross validation for accuracy parameters. And model validation, we use cross validation for accuracy parameters. We can use Bootstrap. Maybe. I don't know. Amrapali says to improve the accuracy of population parameters. Okay. All right. You know, I love this though. I love that you guys are taking a refreshed look at this, because some of you are kind of like revising your previous answers, and your second answers for everybody I've seen so far is definitely more on the right track. So I'm liking where this is headed, right? So I think you guys are successfully coming back onto the right track. So this is great. Nyan, good to see you, Nyan. I know you've attended before, so good to see you. Resampling is done so algorithm learns in a more generalized manner and not succumb to overfitting. Oh, Nyan, Nyan, you're so close. You're so close. You had me at learns, you lost me at overfitting. You're so close. But yeah, Nyan coming in strong with their first message. But yeah, like you had me at learns, you lost me at overfitting. We're gonna get to that, okay? All right, so let me go to the next slide, because what I'm gonna do here is I'm gonna break down the two statements that the authors made that we just saw in the previous slide, right? So this here is the first statement broken down. Samples from a training set. Well, that's just the training data. That's all it is, right? That's just the training data. We know we need training data. That's no surprise. A model of interest. Well, that's what we're trying to find, right? That's the proposed solution, effectively, right? I mean, that's what we're after. That's the whole point, right? Obtain additional information about the fitted model. Well, that sounds an awful lot like the metrics, like the performance metrics, right? So what we're really asking there is, how did our experiments go? Right? So think about these three steps that we're talking about. Where's the data? We're going to fit it into the model, or use it to improve the model. And then what did that do to our metrics? Right? So let me say that again. Where is the training data, or what is the training data we want to use? How does it fit into our model, or improve or modify our model, right? Because I don't want to say improve or deprove or improve or break, I guess, or break our model, right? Because it can go either way. So how does it affect our model, and what was the result of those metrics, right? Doesn't that sound suspiciously like I just described a training cycle, right? Is that not an algorithm training cycle? What is the data? What do you think the parameters for the weight should be? And what happened to the metrics? How did it perform? That sounds like a training cycle, right? Let's look at the next slide. This is the second message that they made, right? The second message that I pulled out from the first slide. Repeatedly draw different samples. Well, that sounds just like training data we want to use, right? Fit linear regression to each new sample. Well, that's the proposed solution, right? And in this case, they've determined that it's a linear regression problem, right? And the third statement they made was examine the extent to which the resulting fits differ. Well, isn't that also looking at the metrics? And how did our experiments go? If we look at all three of these, the training data, putting it into proposed solution, how did our metrics change? Doesn't that sound like a training cycle? So give me a 1 in the chat if that sounds like a training cycle to you, or give me a 0 if it doesn't sound like a training cycle. What do you guys think? Because see, to me, like the authors basically told you the same thing twice. They just said it in 2 different ways. But give me a 1 in the chat if that sounds like a training cycle, or give me a 0 if that doesn't sound like a training cycle to you. I'll give you guys a minute there to vote. So yeah, if you're still on if you're still on Instagram, feel free to join us over on YouTube. The YouTube's format, right now, when I have the classroom view up like this, it doesn't always look so great on Instagram. So if you go to YouTube, you get a wider screen, or you can join us on Twitch. We have our great mod, Rex Riker, over there modding on Twitch. So might be a little more convenient than Instagram. I love Instagram, great platform, it's been good to me. It's just not great on Sundays when I teach this class. Okay, so I'm seeing a lot of 1s in the chat. Right? And yeah, I mean, I think you guys are seeing it, right? Resampling is just a training cycle. It's how algorithms learn. Resampling is just a umbrella word or the concept of how you train an algorithm. Here's the data, try it against the model. Here's what we learned, right? Here's the metrics that changed. But that is effectively what resampling is. There's different ways to do resampling, and those ways have different approaches. But when you think of resampling and the ways to do resampling, you should be thinking about, oh yeah, that's the training of a model. That's how a model learns, right? So some of you mentioned some of these terms that are now up on the screen, right? We saw people mention cross-validation. We saw people mention bootstrap in the earlier conversation. So I don't want you to kind of get confused in those, right? Because when you think about cross-validation is resampling. Bootstrap is also resampling. So by definition, cross-validation is the process that you use it's a process that an algorithm goes through to learn. Cross-validation is a way that an algorithm learns. So is bootstrap. Because the algorithm is going out there, getting the samples, trying it against the model, and then trying it against the metrics, right? And then it makes adjustments and starts all over again. That's just kind of repeats that training cycle over and over again, right? But that's really what you should be thinking about when you hear resampling. Because see, I think some of the earlier answers kind of caught up in the sampling side of, oh, well, it must mean I don't have enough data, or I need to do this, and this, to kind of, try my data over and over again. Trying to get caught up in that, just think about how it's training. It's how the algorithm actually learns. It's kind of like a multi-step process that's just repeated over and over again, but it guides the algorithm to a new solution, to hopefully, not always, obviously, but hopefully an improved model. So in that second step, right, when you try to fit that model, it's going to be better with each iteration, right? So if you remember nothing, well, there's 2 slides I really want you to burn into your minds. This is one of them, right? Cross-validation, resampling, bootstrap is resampling, which means that cross-validation is how the algorithm learns. That's it. That's all it is, right? Oh, excuse me. So I did want to say one thing though, because I did have a third bullet here, but for in practice. This is where I'm giving you like the real world of how this is done out there, right? In the real world, in the current state of data science, you're not all 2 things. One, you're not always explicitly naming or explicitly pointing out the steps for cross-validation or your resampling phase. There is no specific resampling phase. It's usually part of your overall model training phase. And I say that because most libraries will support an individual cross-validation function or method in their libraries. We saw that earlier this week, right? If you attended Tuesday's chat, I did a session on Meta, Profit by Meta, and they happen to have an individual cross-validation method. You're not always going to find that. What you are going to find is you're going to find a fit method. And the fit method is the one where it kind of consumes cross-validation, right? Like the fit method will use cross-validation during its process. It's just not expressly told to you that way, or you're not expressly going to write that in your code. You're not going to call a cross-validation function. You're going to call a fit function, right? So in those terms, you can kind of think of how cross-validation is kind of consumed by a greater fit function. So that's how it's being done in most libraries out there, right? Second thing in practice is that of the two resampling approaches, cross-validation or bootstrap, cross-validation is definitely more dominant. Bootstrap is a lot more convenient when you have fewer samples. But you're not always going to have that choice, or that that's not always going to be something that you explicitly choose. In many cases, the fit function will choose for you, based on how big your training data is, or it'll just use cross-validation no matter what. And that brings its own pluses and minuses. But you're not always going to have to choose, cross-validation or bootstrap. And like I said, in some cases, you might not even know you're calling it. You're just calling it a fit function, right? So I want you to be aware of that, because this is one of those concepts where you want to learn the concept and kind of what's going on underneath the hood, but you're not explicitly going to be calling this in code or kind of using it on a day-to-day basis, right? As an example, when I'm running one of my team meetings and one of the data scientists that works for me is giving me a report on their model or on their progress, they're not really going to say I'm in the cross-validation phase. They're going to say I'm in the model fit phase, or I'm in the model development phase, right? It's just not something that you would explicitly call out that way. It's already kind of happening in the code underneath the hood, because it's really just kind of like the only way that the model is going to learn, right? So just kind of want to give you that real world check on it, that in practice, you're not going to be talking about cross-validation on a day-to-day basis, but it is a critical portion for you to understand in data science. Okay, so let's move on to the next slide. I have 2 slides today that contain the primary takeaways that I want you to remember. And this is the first one. So first of all, realize that this is where the experimentation side of data science begins, right? That process that we just went through, those 3 steps, here's the data, fit it to the model or try it against the model. What did we learn? How did the metrics change? That process, you're going to repeat over and over and over and over again, right? Or resampling is doing that over and over and over again, right? So that's basically the experiments of data science, right? So when I tell you guys, follow the scientific method, choose the experiments, design the experiments, write the code, that's what we're talking about, right? How are you going to fit your data against your model? That's cross-validation. That's resampling, right? So I want you to kind of think about it. This is where it begins. This is where you can say, oh, okay, yeah, I need to run multiple fit cycles, cross-validation cycles, and that's my experiments, right? Here's what I changed in this cycle. Let me mark that down. That was experiment number 1. Okay, let me make these other modifications, or new data came in, or the latest quarterly results came in. Let me run that. Oh, okay, here's what happened then. Let me mark that experiment number 2. Right? Oh, okay, yeah. You know what? I switched from my champion model process showed me that I should be trying another model. Let me try another model. Oh, yeah, here's what happened. Okay, here, let me write that down. That's experiment number 3. Right? And then in turn, that can become in a different format, that can become what you report to your stakeholders, right? Because they're going to challenge you and they're going to say, well, how do you know that this is going to work? Well, here's my list of experiments. Experiment 1, we tried this. Experiment 2, we tried this. Experiment 3, we tried this. And you would have the metrics for each one, because the metrics is a part of the cross-validation, right? So again, this is where the experimentation portion begins. Second thing to remember, this is also where the computational needs come in of data science. So when you hear about, how much processing power data science takes, whether you should be using CPU or GPU or things along those lines, this is kind of where it starts. Because this is where you see the repetitiveness, right? The constant testing that's happening as you're developing these models. This is kind of like the start of that, right? I mean, obviously that conversation gets a lot more complex, but I do want you to understand that you should be starting to be able to see why people say, like, I'm waiting for a training cycle to finish, and why it can take multiple hours, multiple days, right? Multiple weeks in some cases. But this is where that begins, because you're repeating that same cycle, those same 3 steps over and over again, right? The cross-validation over and over again, right? And then finally, if you read the chapter, or you're going to read the chapter, you're going to see some of the same metrics that we saw before, right? We've been focused a lot on MSE, right? The mean standard error. You're going to see that because it's really what you're doing, right? Like when I say, how did your experiment go? What I'm really asking is, did your MSE improve? Right? And that's what you're going to be asking, right? And you're going to be developing a baseline model and saying, here's where the MSE is if we don't touch anything. And then here's how experiment 1 went. Oh, that's a much better MSE. Here's experiment number 2. Oh, that was terrible. We got terrible results. And how do you know that? Because you can compare it against your baseline MSE, right? Or previous experiments, right? Because you can redefine your baseline, right? As the experiments go on. But it doesn't get more complex than what we've seen already. You're still measuring against the same metrics, right? A metric like MSE is still going to be valid no matter whether you did the computations by hand or you had a whole room full of GPUs. It doesn't matter. Did it improve or not? Right? That's kind of like the bottom line. Did you get better or not? Right? So I'm going to pause there and let you guys take that in a little bit. I'm seeing people still join in on Instagram. Welcome. I love that. But Instagram is not always great for today's session. So if you want to switch over to YouTube, get the widescreen view, you can see all the notes and the code I have up on the screen. But thanks for being here. Let me go ahead and look at the chat. I see a couple of different things I want to address. Alan says, Bootstrap not to be confused with front-end CSS framework. Yeah, thanks for pointing that out. Thanks for pointing that out, Alan. He's right. Bootstrap is a concept in the chapter that we're looking at today, and it also happens to be the name of a front-end GUI HTML framework that's available by, I believe that's put out by Twitter. I think Twitter was the originators of that. And by the way, I love Bootstrap. It's a great framework if you guys haven't looked at it. For data scientists, Bootstrap is a great framework to learn because it's so easy to make something look good. I cannot tell you how many presentations I've done using a Bootstrap front end because I can put it together so quickly. So yeah, thanks for pointing that out, Alan. And as a side note, if you guys want to look at Bootstrap, it's a fun framework to work with. Ravindram, we're going to come back to questions at the end, okay? Okay, but I think I've covered this slide enough. Right? But I hope that you guys are kind of starting to get it here, right? We're just talking about training an algorithm. This is the training part of it. Whenever you hear those terms, resampling, cross-validation, bootstrapping, that's what we're talking about. We're talking about building up an algorithm. All right? Let's go to the next slide here. Oh, where am I? Sorry. So they give you 2 ways to do this, right? Cross-validation is the first one. And I'm going to put this up on the screen here. And the reason I'm putting this up here is because, well, let me take a step back here. To me, this is one of my favorite questions to ask in an interview. I ask this in just about every interview that I run. So if you want to work for me, I will ask you, what is cross-validation? Can you please tell me what is cross-validation and why does it exist? Now, I think all of you can kind of guess at the model answer because I basically just gave it to you, right? In what we've been talking so far. That's the model answer for me. The reason I'm putting these definitions up there is because I want you to see how similar they are to what we've already been talking. The problem that I've had throughout the years is that when I ask about cross-validation, and by the way, I'm not going to pick on anybody, but I saw this problem in today's chat and also at the meta conversation. The problem with that question is that people inevitably give me the answer for k-folds validation. So I want you to see what the authors wrote here, because it fits the same approach that we used before, right? Because you can see here, divide the available set of observations, the fitted model is used to predict, and the responses for the observations in the validation set, right? So it's basically the same thing, right? Here's the data, try it against the model, what are the metrics? But people usually end up giving me the answer for k-folds cross-validation. So what I want you to understand is that cross-validation, the model answer for cross-validation is that it's the way the model learns. It's the way the model understands and trains itself. K-folds is how it chooses the samples from the data. That's it. That's all. That's all the difference is, but it's a really vital difference. Because like I said, people usually end up giving me the k-folds answer instead of the cross-validation answer. So I want you to understand it's kind of like the umbrella. Well, the bigger umbrella is resampling. The next level down is cross-validation. And then below that, or a component of cross-validation, let's say, is the k-fold side. Because people also kind of forget that there's still also leave one out cross-validation, right? And just nobody really mentions it, right? That is a valid way of doing it, right? So I kind of want you guys to remember this, because this is kind of where you would start to separate yourself from, not just in interviews, but in your own data science practice, right? Because we're not trying to pass interviews here, right? We're trying to be professional data scientists. And I want you to kind of have that separation in your mind, because this is sorely lacking out there. So if you can do this, you will distinguish yourself among your peers, right? So I want you to think about the answers that you guys have given me and realize that it's not about the size of your data set. It's not about overfitting. It's not about all these other things. It's just about training my model and how I'm choosing the items from my training set, right? Like the process, the theory that I'm using for choosing from my data set, right? Because leave one out cross-validation is significantly different than k-folds, but it's still a way to learn, right? You can still learn via leave one out. And again, I also want to point out that this is one of those things that you're really not always explicitly choosing in your code. You're not always saying, well, I want you to do cross-validation and I want you to do it via leave one out, and it has to be via k-fold, right? So this is more about understanding the theory and the process, but in the real world, you're just going to be using like a fit function to help you come up with the model. The libraries kind of compress all of that for you into a fit method, a fit function, right? All right, so back to participation. I have a third bullet on here. And the authors talk about this. Remember in the previous classes, we've talked about qualitative and quantitative problems. Oh man, shoot. I'm sorry, guys. I have an error in here. It's not quantitative, it's qualitative for this question. Quantitative is when you have like a specific value or specific number you can give, right? Whereas quantitative is more about like categories. or some sort of a classification, right? A lot of you have attended the previous session, so I'm sure most of you understand this, right? So, what about qualitative problems? Those classification problems where we're getting like a classification or a category answer. How do we have to treat those differently during resampling? So have a minute to think about that and let me know in the chat. What about qualitative problems? How are we going to go about those? The authors tell you, but they don't tell you. But, you guys are all smart. I see this chat. You guys are a really smart chat. What are we going to do about those? What are we going to do about qualitative problems? Let me know what you think. I'm going to be reading the chat here, but you guys tell me what's going on. Give you guys a minute to think about that. Again, reminder, if you're on Instagram, love Instagram, but these classes are just better on YouTube or Twitch. Okay, Ravindran is offering up the first answer, and he says confusion matrix. Give me a little bit more information there, Ravindran. What exactly do you mean, please? Sarvesh, welcome. I don't think I've seen you before, Sarvesh. So welcome to the class. We use encoding to convert it into a quantitative problem. Okay, Sarvesh. I think you're on the right track. Take what you just wrote and take it just one step further. Take it one step further. But you guys are welcome to write about qualitative problems. How are we handling those? The authors, I think if I remember right, it's like a little subsection in one of their chapter sections. But what about qualitative problems? Okay, Hamad says agree with Sarvesh. So Hamad, take Sarvesh's answer one step further. What does it mean? What does it mean for everything we just discussed? What does it mean for the next slide that I have on qualitative problems? What are you expecting to find on that slide for qualitative problems? Ravindran says, I didn't get what's the question. Could you explain it, sir? So Ravindran, thank you for the clarification. Good job. A data scientist always asks for clarification. We know that there's quantitative problems when you're trying to do like some sort of like dollar value or something that's measurable, right? A scalar value. And we also know that there's qualitative problems where it's like a class or a category, like when you're trying to do like a yes/no question, right? Those are two different types of problems in data science. What do the authors say about the difference between qualitative and quantitative problems and resampling? That's the question. Anybody else? A little bit less participation on this one, and I'm not surprised by that. Give everybody another 30 seconds or so here. I still see people popping in and out of Instagram. Love seeing you here. Thank you so much. Feel free to switch over to YouTube and you can see the widescreen format so that you can see the entire class layout and all that. Sultan, question is not fully visible. Yeah, Sultan, I see that you're on Instagram. Feel free to watch us on YouTube. Data Science with Dennis is my channel. I'm live there now also, and it gives you a better view of everything on my screen, okay? But thank you for that feedback. Okay, Rex says, yeah, this question has me scratching my head. Okay, Rex, okay. All right. Okay, so I think I've given enough time. You know, Rex, I'm gonna just assume that you scratching your head is maybe rooted in suspicion, right? Because you guys know I like to give trick questions every once in a while, right? And this is a trick question. The answer is there is no difference, right? There is no difference in qualitative versus quantitative problems when it comes to resampling. Because that theory, right? Remember these 3 steps, right? Here's my data. I'm going to try it against the model. Here's what my metrics say about my latest experiment. That's the same for everything, right? That doesn't change. Those 3 steps are a fundamental building block of data science, right? So it's a trick question. There is no difference for qualitative problems, right? So I want you to remember that what we're talking about is one of just the most fundamental, most important things in data science. You should be doing this no matter what. You're going to be doing this really, I mean, for the majority of your career, all of your career, right? There will be no project where you're not using cross-validation, bootstrapping, resampling in general, right? Training cycles, right? This is the work that an algorithm goes through to build itself up, right? The repetitiveness of it, the experimentation side of it, you're always going to be doing it, right? So Rex says, yep. Yeah, Rex has attended enough of my live streams to know that I like to throw trick questions out there for you guys, right? So when I said, you know, what does qualitative say about, what do I say about qualitative problems on the next slide? There is no next slide. I'm not gonna, there is no need for me to highlight qualitative problems because it doesn't change. You're always going to be doing this. There is no different training cycle for qualitative problems. So if we go back to Sarvesh and Hamad's answers about encoding it to convert into a quantitative problem, that's like a step in the process, yes. But there is no difference, right? You're still going to go through that same cycle, right? You're describing the tool to how to get there, and that's great. I commend you for that. It's an important part, and we cover this more in future chapters, right? The encoding side, I mean. But the process itself is still the same, right? Whether you're using a qualitative problem or a quantitative problem, doesn't matter. You're going to go through this over and over again. Okay? I want you guys to remember that. So, going to the next slide. Give me just a second to peek ahead. Yep. So, this is what I would consider a model answer when somebody like me asks you in an interview, what is cross-validation? Right? It's the process the algorithm goes through in order to learn from the training data and create a model that can be used to predict future instances. That's what cross-validation is. Or you could say the same thing for resampling, right? That's what resampling is. There's different ways to pick the data, whether you're using k-folds or leave one out, but this is what cross-validation is. So don't confuse the two, because again, when I ask this, people give me a k-folds definition. But this is what cross-validation is, right? It's data science, right? It's one of the fundamental building blocks of data science. And here's another definition I've also used. It's like when you were in school and the answer's in the back of the math book, right? What do? You go through the problem, you try your best, you apply what your teacher told you, and then you go in the back and say, oh yeah, I got it right, or oh no, it went terrible, here's where I went wrong. Is that not cross-validation? Is that not what we just talked about? Right? The data. You tried your best to solve the data, to solve that problem. How did you do? You go and check the answers in the back of the book and you say, yeah, I did good, right? The process I just followed, the model I just created in my head for that math problem, it worked. I'm going to continue doing that because it worked. Or no, I did terrible. I need to fix my process. I need to adjust something, right? That's cross-validation. That's resampling. That's learning. That's training an algorithm, right? And the reason I give you these two slides is because maybe the first one maybe, but certainly the second one, this is what I use to explain to my stakeholders, right? This is how you should be talking to the business, right? I want to bring this all together back for you guys because again, we're being professional data scientists, right? This is what the type of explanation I want a data scientist who works for me to be giving to the stakeholders, to the business, right? I don't want you talking in math and code to them. I don't want you explaining k-folds to them, right? They don't care how you're selecting the data, how you're generating your samples. Right? To them, you could be using a room full of monkeys to select your samples. They don't care. But this is how you should be explaining it to your stakeholders. Right? Because some of them, you're going to get this question. I've gotten this question hundreds of times in client meetings or with stakeholder meetings. Well, Dennis, when you tell me like it learns, like, what are you talking about? Like, how does it learn? What are you going to do? Right? Or sometimes, you're going to get clients who are aggressive. How do I know you're training this right? How do I know these crazy math algorithms are going to be correct? Well, because we put it through a process where it comes up with answers and checks itself. We put it through a process, we enable the code to be able to try your data, and it'll try one way, and if that way doesn't work, it'll fix itself and start all over again. That's how you want to explain it, right? You just managed to explain cross-validation without looking like a math nerd. So I'm giving you guys stuff like out of my own playbook because this is stuff that I've used with clients. But this is what you want to be explaining as far as what some of these items are, right? Whether it's in interviews or, as you go on to work or things like that. Okay? So Ravindran is putting out a good question on the chat. Is cross-validation used in supervised learning? Anybody want to help Ravindran out? I'll leave that with the chat. You guys can answer that. I'm going to move on in the slides, but if you guys want to think about that and you want to help out your fellow, data science student, Ravindran, I think, is asking a pretty interesting question there. All right, so on the next slide, we're going to talk about Bootstrap. And I got to be honest with you guys, I kind of hesitated to think about whether we needed this section or not, right? For a couple of reasons. One, like I said, you're not always going to be explicitly, you're not going to be explicitly calling resampling per se. You're not always and then when you're not always explicitly going to be saying, well, it has to be cross-validation or it has to be Bootstrap. That's not really a decision you're going to be making on a practical basis, right? The second reason why I hesitated to do this is because the overwhelming amount of projects that you're going to be working on are going to be deep learning projects, right? We are living in a big enough, technology age where basically everything is measured out there and there's plenty of data for just about anything you need, right? I mean, it may not be easy to get, you may not know where to get it, but the data is out there, right? For just about anything you need. Like, there's really not as many small, there's not as many instances of projects where you're going to have very few ground truths to work from, right? Like a really small data set, right? So bootstrapping, I think, is still valuable for you to know on a general basis, but we're living in a deep learning era, right? Or I should say in a big data era, right? So yes, I think it's fun for us to go over this, but just keep in mind that, the explicit needs for this is going to be not nearly as big as you think. Okay? And what really drew me to this was this chart, and obviously the charts I'm giving credit to the authors for, but this chart here is straight from the book. And the takeaway that I want you to remember is that the difference in bootstrapping is that you are allowing samples that contain the same instance of the same data, right? So you can notice here in the first example, it uses observation number 3 twice. Down here, it uses it in observation number 2 twice. So, that's not really common, right? There's not a lot of instances where you're going to say, well, I need to repeat my data in that way, right? I mean, where you're going to find this, and the reason why it's called a bootstrap is because maybe there are times when you need to take a smaller data set and build it into a bigger one by using a kind of like a temporary algorithm to help you, right? So for example, we very briefly covered in the past how you can have a set of data that's not labeled, right? So that's an unsupervised problem. If you wanted to, and if the data in the project lends itself to it, you can turn an unsupervised project into a supervised one by labeling your data. That's a valid strategy in some cases, right? So that's an example of where you might use a bootstrap approach, where you can maybe manually label a few records, create a little temporary algorithm, a bootstrap algorithm that's going to take those labels, learn from them, reuse them in a similar way that's up on the screen, and then you're using that algorithm to further train other unlabeled data sets, and so on, right? You kind of you take this small data set of 5 samples and you turn it into 20 samples, and you turn it into 60 samples, and then you turn it into 80 samples, and then all of a sudden you might have something you can work with, right? So that's kind of like where that bootstrap approach comes from, where in those early stages you have to reuse data, right? You have to reuse your samples, and that's what's being illustrated in this chart. But again, that's not really going to be a common thing, right? It's not always going to be something that you're going to need, because so many projects that you're going to be working with are going to be big data projects. Okay, so I hope you guys are with me on that. If not, let me know in the chat. All right, let me go back to the chat. Remember, the question in front of the chat right now is coming from Ravindran. Is cross-validation used in supervised learning? So let me know what you think about that, chat. Ravindran says, Ravindran adds, because based on the definition, it compares only in supervised learning, data is labeled, i.e. only correct pairs. Is he right? Let me know, guys. Yassine says, I think it is used only in supervised learning as it requires the existence of labels, outputs, and targets. Okay. Who agrees with Yassine? Let me know. Ravindran says, in simple terms, is bootstrap multiple randomly picked sample space from a single data set? Well, Ravindran, that definition can fit cross-validation also, right? So yes, the randomness is part of it, but it's part for both cross-validation and bootstrap. The difference for bootstrap is that you can reuse samples within the same training set, which typically you wouldn't need to do, right? But that's the bootstrapping aspect of it. Okay. Mahmoud says, I can't watch live now. Will you be posting it later in your account, please? Yes. As soon as the session finishes, it's archived on my YouTube, and then I usually put a notice on Instagram to say when the replay is available. But yes, Mahmoud, you're welcome to watch it afterwards. Everything is posted there. Thank you for the question. Sarvesh says, wouldn't bootstrapping change the distribution of training data? Yes, absolutely it would, Sarvesh. That's a great observation. And that's one of the I don't want to say dangers, but that is one of the results of bootstrap. that you are kind of, you're introducing a lot of new risks into your training, right? But again, this is one of those situations where you're only going to do it where you have very, very limited data and there's no hope of getting more data, right? When that happens, that's when you want to say, okay, let's try this bootstrap approach, right? Like you basically just say, I have no choice but to reuse my samples, right? So yeah, it does affect that distribution, right? But what else are you going to do, right? But you can use the bootstrap in the manner I just described so that you can get to a point where you don't have to do that anymore. You can turn, I don't know, 20 labeled samples or whatever the case, a small number of labeled of now labeled samples to a point where you can now use something else, right? Like I said, turn an unsupervised problem into a supervised problem and move up from there. But those initial stages are still a bootstrap approach, and that's where the bootstrap term comes from, right? If you guys aren't familiar, well, I don't know this for a fact, but I'm guessing that this whole bootstrapping name comes from software development, because in software development, there's a similar concept of bootstrapping, right? How do you write a new a new software development compiler? Well, you got to use another compiler to help you write the initial parts of the code to bootstrap that the new compiler, the one you want to write, up, and then you can use the new compiler to compile itself, right? It's the same process or the same concept here. Okay. Amrapali says, I think cross-validation is used in unsupervised as well. All right, I appreciate that answer. Who agrees with Amrapali? So we have people who say that it is only for supervised, and people who say it can also be for unsupervised. Joseph says, following Sarvesh's question, is there a way to measure the degree to which a distribution has drifted or changed? Yeah, that's statistics, right? You can do a distribution on your own, right? So in this case, you would do a distribution of your X column, right? Because that's your independent variable. So yeah, you would just chart that out. What is the distribution of X now that you've included observation number 2 twice? Yeah, you can graph that out. It's just a standard distribution in your, that you would do in any statistics package. Or in this case, if we're assuming linear regression, you would just, maybe do like a new scatter plot or something, right? But yeah, you could do that. Ravindran says, is that possible to change the sampling method in Bootstrap? Yeah, but then it's not Bootstrap, right? Then you could be saying you're doing more of a cross-validation approach, right? Because Bootstrap without the ability to repeat samples is cross-validation. Now, if you have a small data set, that's not going to go well, right? In some cases, your data set might be so small that you can't even do an effective randomization because there's not enough there to choose effectively, right? But yeah, you can do it, but then you're not bootstrapping anymore. All right, good questions, guys. Good questions. I think this might be the last slide. Oh, okay. So this is the second takeaway. And this is the last slide before we start looking at some code, right? So this is the second takeaway. Cross-validation, and again, this is me telling you guys as far as like, using the proper definitions and the ways I've seen people maybe not do so great in interviews with me. Cross-validation is how the model learns, right? K-folds is how those samples are chosen and managed. Same thing for leave one out, right? Leave one out is a little easier. It's kind of self-explanatory. But I don't want you confusing these two because again, I've received the definition for K-folds when I ask about cross-validation. All right, so this is the second slide I want you guys to burn into your brain. If you remember nothing else, remember this slide. Because it's a popular interview question, right? To ask about cross-validation. So I'll leave it up on the screen. Aya says, hey Aya, nice to see you. I think you're also one of our Discord members, so welcome, Aya. Feel free to switch over to YouTube, Aya, because that will give you a better view into all the code and stuff. We're about to get into the code, so that might give you a better view than Instagram, but thanks for joining the class. All right, so let me check here, but I'm pretty sure we're going into the coding next. Yep, okay, so we're going into the framework and coding next. So before we leave this deck, right, because we're going to switch over to VS Code, any questions or any other thoughts? But again, we are going over one of the fundamental building blocks of data science. I mean, this is where the rubber hits the road with data science, right? Aka says, can you give the link for YouTube? You know, that's an excellent question. Let me see if I can't bring that up for you, Aka, and for Aya too, because I think Aya wants to switch over. Give me just a second. You know, it's in my Instagram stories if you want to look it up there. But I should have that handy. Yeah, it's right here. There it is. Okay, I'm going to drop it in the Instagram chat, guys. Okay, it's in the Instagram chat. If you guys want to switch over to YouTube. All right, so we're ready to go on to code. Last call for initial questions. You can always ask questions at the end, guys, right? But I don't want to charge forward if there's something out there. All right. So the framework we're going to follow is the same as before. If this is your first time joining, I'm going to go over it, but this is the same framework we've been following, right? My way to pay my respects to the authors and build upon their work, right? Because we're not copying their work. I'm trying to build upon their work. Is to do this via AI, right? So we're going to be level 2 data scientists and thinking about this in how we can go about using AI and not start from a blank screen. Because that's going to be the future of data science and we're preparing now for it, right? So we are going to be code editors, not code writers. We're going to be using ChatGPT. And we're always going to make sure that we have some result that we're optimizing for, right? You can't be a data scientist. You can't measure results unless you have something to measure against, right? So we want to be cognizant of those metrics that we are putting ourselves up against. Okay. So what are we going to do? We're going to use a professional level development environment. We're going to find an appropriate data set. We're going to put cross-validation on a model. We're going to provide all the metrics. And we're going to also make sure that we're presenting the final iteration of the code in a professional manner, right? A data science professional writes programs, not scripts. Python is a very capable language, and we can certainly do that, okay? All right, so let's get started. Again, if you guys need anything, you know, kind of blown up on the screen, let me know. But now is we're going to go to ChatGPT and we're going to be using VS Code. All right. So ChatGPT, let's get started. First, we're going to ask about the frameworks that it knows. So it's using scikit-learn, TensorFlow, and Keras, which is great. It's using XGBoost, or rather it knows about XGBoost, LightGBM, another gradient boosting. PyTorch is for the homeless, so we don't want to use PyTorch. And that's it. It showed us 5 frameworks. Okay. All right. Well, in the previous examples, we've been using scikit-learn, so I think we should proceed with scikit-learn and see what it gives us. All right. It looks like it's going to use the iris dataset, which is a common dataset for data science. What do you guys think? Can you guys see the code? Actually, you know what? Let me bring that code into VS Code. I think it shows up just a little bit bigger on the VS Code side. We're going to start a new file, and we're going to call this CV. You know, let's just call it CV version 1 in case we do others. We may or may not do others. All right, so there's the code. What do you guys think? Anybody see anything jumping out at them or anything? Alan Valdez says, "Good job, ChatGPT. Looks like our code work is done." Yeah, maybe. Yeah. Remember, this is the blank screen effect that I have, right? You never want to start with a blank screen anymore. So yeah, it's given us a pretty reasonable code. Now, however, Alan, I think you said this is your first time joining. Remember that in other classes, we have seen ChatGPT make some mistakes, some very basic mistakes in some cases. So again, we're being editors. We can't just take it wholesale. We have to kind of still work it ourselves, right? But, you know, it's always good to just kind of just take a step back and just do like a smell test, right? Like this is what in software development you call a smell test. Does that code look good, everybody? Anything jumping out at people? Just give me your observations if there's any out there. There may not be any observations out there. That's okay. But let me know if there's anything jumping out at you. What do you guys think? What are we doing in this code? Think about all the stuff we've covered up to date in this book, right? Even in the other chapters. What are we doing? Alan says, does the variable get called after line 16? That's not a variable, Alan. That's not setting a variable. That's setting the parameter that's needed by cross-val score. So that's not a variable setting. That's setting a parameter. Good question, though. And you know what? In line 16, there's a lot happening in line 16. So if anybody wants to look at that and just give me your assessment. Like, does this pass the smell test? Ravindran says, can we add another model to compare the performance of both models? Yeah, of course, Ravindran. But, you know, walk before you run, right? We got to get the initial code base off the ground, right? And then we can make those adjustments. Right now, we're still kind of in a learning phase, right? What you're describing is a little bit more like a champion model process, which is great. I encourage that. You have to do that. But let's flesh this one out a little bit more, right? So look, Ravindran, let's build on your question. What model are we using now? What does the code tell us about that? And, you know, like Alan, what does the CV parameter represent here? Ahmad says, looks good. Okay. Anybody else? Or just give me your observations or anything that pops out at you. I see 1, 2, 3, 4 things that pop out at me in this code. I mean, generally, I agree with Hamad. The code looks good. I think this is runnable code. I think we can use this as a jumping off point. But you know, we gotta exercise our own abilities, right? We gotta make our own assessment and see if it passes the smell test. What do you guys think? Okay, great. Yassine, wonderful. Great observation. It's using the k-folds cross-validation. Yeah, that's exactly right. So Alan, coming back to your question, that's what the CV value is, right? The CV parameter. Amrapali says CV is the number of cross-validation folds you want. Yeah. Yeah, great. You guys identified that correctly. We're going to be using cross-validation, and it's going to be a k-folds, right? We know we're not going to be using leave one out. All right, so that's great. That's one of the 4 things that jumped out at me. What else, guys? Anything else jump out at anybody? But you guys are doing a great job so far. Okay, Yassine says it's a classification problem. Yeah. What kind of classification problem? Okay, Ravindran. Ravindran basically just answered my question. We are using logistic regression, which does binary tasks. That is yes or no. That's right. That's right. So it's a classification problem, you know, between 2 classes essentially, right? So Yassine and Ravindran, you know, are both correct in that. And we're using logistic regression, right? So yeah, you guys did great on that. So the other thing that caught my eye is that we're using the iris dataset. I think most of you are going to be aware of this, but for those of you that are not, the iris dataset is a classic dataset in data science. Every student on the planet has used the iris dataset. And it's one of the datasets that's natively available within scikit-learn, so you can use it too. The authors also use the iris dataset in some of the examples in the ISL book, so you're going to come across that when you see mentions of iris. But iris is a classic dataset, so I'm glad to see that we're being exposed to it today. We're also the other thing that caught my eye is we're setting our x and y, right? So we know that from our previous classes that x is going to be our independent variable and y is going to be our dependent variable, so also known as our target variable. So you see the target being noted there. And yeah, and then the last thing that caught my eye was down here, right? This is where the rubber hits the road, right? The cross-validation score is where the actual execution takes place, right? That cycle, that 3-step cycle we talked about, here's the data, put it against the model. How did we do? That's where that's happening, all in line 16, right? So line 16, like, is the thing, right? And also where the heavy lifting is. So when we talked about like those CPU cycles, the computationally intensive side of data science, that's where it's happening, okay? Okay, so Ravindran says it gives calculations of recurrent events based on the input. Yeah, it's going to give us the metrics, sure. Yassine says, however, maybe ChatGPT has made a mistake because the iris dataset is more than 2 classes of my knowledge. Yes, you're right about that, Yassine. There are multiple classifications, but it all just depends on how you structure the data, right? But yes, we could be doing this for a multi-class, but let's keep it logistic regression for now, okay? But yes, I fundamentally agree with you. Ahmad says, we loaded the dataset of sklearn, which divided into x and y, dependent the model, we will use logistic regression. Yeah, Hamad, that's a pretty good summary. Yeah, so I think that, so the bottom line is I think this is perfectly reasonable code, right? I expect that it will run. Nothing jumps out at me as being wrong. VS Code is not telling us we have any, anything that's blatantly wrong. So let's run it. All right, CVV1PY is what we call this. So now we go back. Okay, and just in case you guys missed it, right? We're not using notebooks, right? We're using an IDE tied to our terminal. Again, if you need the code bigger or the terminal bigger, let me know. But we're gonna make sure our file is there. We're in the right directory. I think we are. Yep, there's our file. So now it's gonna be Python. Let's see what it says. So these are the scores it's giving us. It doesn't explain exactly what scores they are. I'm going to assume that these are accuracy scores. What do you guys think? Is that an effective output? Remember, this is the metric that we're measuring, right? Is this a good way to look at it? I think we've seen other ways that might be a little better, yeah? So let's modify this code. I think we need better metrics. Let's go back to our ChatGPT employee. Wow, that really expanded the code, eh? And it's going to give us a aggregate confusion matrix. Let's go ahead and create a new file. All right. So generally speaking, the top part is the same, right? It's going to use a different approach to k-folds. And then it's going to go ahead and do different splits of training and testing. It's going to create the confusion matrix down here. It's going to maintain a list of confusion matrices down here. And then it's going to show us the individual results, but then also show us an aggregate of the confusion matrices. So it's reasonable code, but a little bit messy, I think. But let's see how it runs. I think there's better ways for us to kind of optimize this code. But we're not going to be too strict about that, because ultimately we still just kind of want to learn from this code, right? So let's see what this gives us. Oh, did I? Oh, I didn't save it, excuse me. Okay. What do you guys think? We saw some mentions of confusion matrix previously, right? A couple of you mentioned confusion matrix, right? Amrampali, did you say no? No, it's unclear. Did you mean to say unclear or clear? Help me understand, Amrampali. Hamad says standard deviation is high. Maybe model is overfitting. Maybe. We would find that out in future iterations, right? Or as Ravindran pointed out, we could also try different models, right? Alan says one is the mean, the other is the standard deviation. Yeah, I think you're right for the bottom result on it, Alan. I think you're right about that. Ah, okay. Alan says, what are confusion matrices for? That's a good question. Anybody want to help Alan out there? Okay, so Amram Pali says, sorry, I meant previous code was unclear if evaluation meant. I agree, Amram Pali. I think there was a lot of improvements that could be made there to those metrics. And I think confusion matrices kind of get that, right? Or get us closer to that, right? But yeah, I agree. It probably wasn't the best for what we need. Hamad says, not clear because of the chat. Okay, Hamad. Yeah, you're right about that. Let me see what I can do about that. It's to the side, isn't it? So maybe if I move this. Oh, let me put that down. Does that help, Hamad? If I move this to the side, away from the chat? I think that should make it easier to read. Let me know if that's a little better, guys. So Ravindran is trying to answer Alan's question. Alan asked about confusion matrices. Ravindran said it's mainly used for evaluating classification models. Okay. So Ravindran, take it a step further. What do you think about this matrix? Because we're looking at this bottom matrix here, right? And you know what? I think ChatGPT can improve on this, guys. So let me go back real quick. I think we can get it a little bit better. I only want to show the aggregate matrix. And I want to show labels, right? Let's see how ChatGPT does on that. So using the same approach, it's using the aggregate and then aggregate confusion matrix. Okay, this looks reasonable. Let's use this latest version. We're going to call this version 3. Let's go and try and run that. And I'm going to clear my screen right now to help you guys a little. Okay, there we go. Now what do you guys think? And by the way, I think it was Yassine that mentioned this. Yassine, you're right. Here, it's going to go ahead and show us the different classes that are available in the iris dataset. Right? It's showing us the 3 classes in this confusion matrices. In this confusion matrix. Explore the beauty of nature, trying to answer Alan's question, says, confusion matrix are evaluation metrics to compare true positives, true negatives, false positives, and false negatives in classification tests. Nice. I'm on board with that description. Amram Pali says confusion matrices will help us understand true positives, true negatives, false positive, negative by comparing the predicted labels with the actual labels. Nice. Very, very well said. Aditya and excuse me, I am annoying. Love seeing you on Instagram, but maybe if you want to switch over to YouTube, it's a little easier to see there, okay? All right, so what do you guys think about this confusion matrix here? What is it telling us? Did we do good? I think I can make that just a little bit bigger. Is that getting any bigger? Yeah, that's a lot bigger. What do you guys think? This is the answer we got for the aggregate confusion matrix. In this matrix, which true positive and true negative and other is confusing? Okay. No idea. How can I interpret that? Okay. Thanks for your honesty, Alan. You know, it's not always easy to admit when you don't know something, but that's a very valuable skill for data scientists, right? Data scientists should know when they can speak from knowledge and when they can't. So kudos to you for stepping up and saying, hey, I don't get this. Yassine says it looks okay for this specific problem. Okay. Why, Yassine? Why does it look okay? Like, what's your rationale for saying that? Because some people in the chat are saying, hey, I don't know, right? So help us understand your rationale. There's no wrong answer here, guys. I just want to see the rationale, and I'll walk you through it, right? We're gonna all learn this. I'll give you just a chance here to look at it. What do you guys think? Wow, guys, we are approaching 2 hours. Good for all of you guys for hanging in there. I just looked at the clock, and we're at an hour 45 right now. Wow, you guys are amazing. All right, so I love the fact that we can go over confusion matrices right now, and we're using this to evaluate our model. But by the way, understanding a confusion matrix, invaluable skill, right? And that's actually a question I ask. I ask, what is a confusion matrix and what does it tell you? That's one of my interview questions. So it's good that we're able to go over this right now. And what we're about to cover, I'm going to walk you through this. Keep in mind, you're going to be doing this throughout your career, right? Because this is basically like you using your mind to analyze and say, oh, okay, yeah, I'm on the right track, or no, geez, that was terrible. What am I doing, right? Okay. So Yassine says, because it only has made 4 guesses wrong out of 150 in a specific problem, I think we can afford this amount of mistakes. Okay. Okay, Yassine. So Yassine is saying that we've only made 4 mistakes out of 150. Some of you may be wondering how he came up with that. And he's right. You know, his read on that is correct. So let's go over that. So the first thing you should know is that the iris dataset is about that. It's about irises. It's about flowers. And within those flowers, within irises, there's different types of flowers, different types of irises. There's setosa, versicolor, and virginica, I guess it's pronounced. So you can have 3 classes of irises, right? So this algorithm that ChatGPT wrote for us is trying to establish taking data like the petal length and the color and the size of the flower and guessing which of the 3 categories it fits into, right? So that's what's represented in the columns and rows. The Tosa, Versicolor, Virginica, those are all of the possible categories that we have trained the algorithm to learn. So you'll notice that it's the same values on the rows and on the columns. The rows usually represent your ground truth of what the model actually says they are, versus what the columns represent your predictions or what the algorithm said they are. Right? So here you can say that for setosas, the data set contained 50 instances of setosa, and your algorithm correctly classified 50 of them as being setosa. It didn't choose any of the other ones. So in other words, we were perfect for Setosa. Our algorithm did not make any mistakes in identifying the Setosa category of irises. Okay, so now we go to the next line down. Now we're saying for versicolor, it put 47 as versicolor. But in 3 of the instances, it should have been versicolor, but it chose them as Virginica. So that is how many errors? That's 3, right? 3 errors. Because it should have been under versicolor, but it put him under Virginica. Of the Virginicas that are in our training set, right? Or in our train test set, it correctly identified 49 of them as being Virginica. But 1 was classified as versicolor, which is incorrect. So the 3 plus 4 is the errors, right? That's how many errors the algorithm made. And the 150 that Yassine mentioned earlier is because we know we had 50 Setosa, 50 versicolor, 50 Virginica, total processing, total predictions or categorization tasks of 150 times. And in those 150 times, 4 were errors. So that gives you an accuracy, right? That's the whole point of that. But as you can clearly see, though, the accuracy rate differs according to the category, right? Each category can have its own error rate or accuracy rates, right? For Setosa, we're perfect, right? The algorithm didn't make any mistakes. For versicolor, we made 3, which is what, a 6%, right? 6%-ish rate. And down here in Virginica, it made 1 error, which is like a 2% rate, right? So that's why these matrices are so important, because now you're going to make some changes, and then you're going to see what the next matrix is, and the matrix after that, and matrix after that, and you can kind of get a sense for where you're going with your errors, right? So Ravindran says, yeah, Ravindran, you got it right. Yeah. Setosa is correctly predicted. Versicolor is predicted 47 times, and Virginica is 49 times. Yeah. Amrapali says, yes, on board with Yassine. Yeah. Yeah, I think Yassine gave a pretty reasonable answer, right? So again, I don't like calling on anybody. I don't want anybody to feel uncomfortable, but let me know. Are you guys a little bit more clarified in confusion matrices? Give me some feedback here, guys. That process that we just went through of interpreting the confusion matrix is exactly something you're going to do over and over again in your life, in your practice of data science, okay? Alan says, can you tell us what you asked ChatGPT to do in order to get this single matrix? Yeah, sure, Alan. I'll go back to that screen. Here. Is that clear for you guys? Or maybe you need a little bit bigger? I think, let me bring up like a text editor or something where I can show it a little bigger. I love the question, Ellen, so I want to make sure I invest time in answering your question. Here was the revised prompt, Alan. I think you guys should be able to see that pretty good. So, a couple of key things in this prompt from my experience of using ChatGPT. ChatGPT is not good about keeping the current state of the code you're working on and modifying changes. So I've had instances where unless I tell it to keep that code and be very specific about the changes, it'll write a whole other code, right? Like it'll turn logistic regression into regression instead, or just make these huge changes where you really just want a small change. So in this prompt, you have to be very specific about what you're asking it to change, right? You have to be very specific and say, this is what I want you to change, but keep the same code. Or in some cases, you'll see me say, I like this code, label this cross-validation version 1. Like you kind of bookmark it in the ChatGPT history, right? In the ChatGPT context. So this is what I used, Alan. And again, here I'm being explicit about saying only label or only change certain things. Because otherwise it'll make changes to the other parts of the code and then you know, kind of stinks, right? But that's what I use. Great question, Alan. What made you choose just the aggregate confusion matrix? Because it's helpful to see the folds along the way to kind of see how the algorithm is learning, but we just care about the bottom line, right? We're not going to deploy the folding instances of the algorithm. We're going to deploy the final model, right? So that's why I asked it to only show the aggregate one. It clears up the screen a little bit. And like I said, the other ones really aren't as relevant as they could be, right? Because that's not what we're going to deploy. That's not what the final model looks like, right? So that's why I did that, Alan. But let me go back to the terminal. But yeah, but look, I mean, let's take this another step further, right? How do we interpret this to the business? Right? We can say that we're pretty accurate, right? We're accurate overall. There are still some errors, but overall we have pretty good accuracy rate. In some classifications, we're going to be pretty good. In others, we might need a little room for improvement. But you present the business with what these numbers are, right? We're really good at Setosa. We're almost perfect on Britannica, and Versacolor might need some work. And that's it. That's all you present to them. You present them with the options, right? To say, hey, this is what the model will result. This is what it will do. And then the business can decide on, you know, mostly it will just involve the dollar values that are associated with each of those decisions, each of those errors in some cases, right? And then they'll tell you, yeah, that model looks good. You know, we can live with those results, or no, you need to modify a little bit. But the point I'm trying to make upon you guys is that's not your decision to make, right? You're a data science team, not a business team. So you're going to have to, you know, take something like a confusion matrix, write up a report on it, and translate that report into options, and then let the business make those decisions on those options, because that's ultimately, you know, kind of what they do or what they're best at, right? But I hope that made sense as far as the confusion matrix. But this is really kind of, you know, what you'll be doing as far as saying, yeah, this model's great, or no, this is terrible. Sarvesh says we can use Claude 3.5 Sonnet's artifact feature for coding. Yeah, sure. But I mean, basically all LLMs can do coding. It's just how much you're going to pay for it, right? On ChatGPT, I do have a paid membership. So, you know, I'm doing that because presumably when you would be doing this for a client, it would also be under a paid membership. But yeah, you can use Claude, you can use ChatGPT. I don't like how Claude limits the hours. You know, they do limit how much you can use it, and I'm not on board with that. So I much rather pay for ChatGPT. I like their tools. But yeah, there's a lot of tools you can do this. Ravindran says, shall we increase the number of folds to increase its accuracy? Maybe. Do we need to increase the accuracy, Ravindran? Yassine said it actually looks okay, right? We only made 4 errors. You got to know when to stop, right? I mean, you can't just, you know, refine models forever, right? Businesses will give you a deadline. I think, you know, the model, depending on the applications, right? You know, this is going to be a useful model for a lot of applications, a lot of business use cases. So do we need to go further? Alan says, can we benefit at all from visualizing the final result? Sure. Yeah. People visualize the confusion matrices, but keep in mind that you do not want to show that to your stakeholders, right? Even this level of math is too much, right? One of the teams I've led, when I was first assigned to lead them, I walked into one of their meetings, like it was like my second day, and they were showing confusion matrices to the business, and I just about died. I was like, oh, like just like choking, like, what are you guys doing? Don't do that. So yes, you can visualize them. It's very helpful to look at the proportions, right? There's some proportions here that we could be changing, right? But leave it in the team room, leave it in the data science team room, okay? You should be taking that, creating your own results, writing those results in business language, and then that's what you present, okay? But great question, Alan. Ahmad said ChatGPT uses 4% mini model after research. Yes, it does, Hamad, but only for like an hour, I think. They throttle it. They throttle you to like I think it was either an hour or 10 queries or something like that. They don't let you just sit there and go forever. It's very highly throttled for 4.0. They'll switch you to 3.5, I think, and that is free. And that coding engine in there is good enough. But 4.0, you can only use it for a limited time. 4.0 mini, you also mentioned. 4.0 mini is a little better in code, but it still makes mistakes, so be careful with that. Rex is asking an excellent question. How much of a code writer do you need to be in order to become a code editor? Yeah, Rex, really good question. And that is a little bit of a challenge, right? Because you do have to have some base level of knowledge to be able to say, oh, wait a minute, that code doesn't look right, or whatnot. You know, Rex, a lot of this might just, I'm assuming somebody has, very limited coding background. In that scenario, it's going to be a lot of experimentation on your part, right? A little bit of trying different instances of code that ChatGPT gives you, running it, and then fixing the errors, right? Because Python will tell you when there's errors, right? And again, we saw that in the first class. In fact, Rex, I think you were there, right? Where they will make mistakes, right? And then the Python interpreter will tell you where the mistake is, and then you have to go and research that mistake on your own, right? So I think it's just going to be that process of, okay, well, that looks good, but let me run it. Oh, okay, here's the error. Let me go look at that mistake. Let me go look that up. In some cases, as you develop that skill more, you'll be able to see the errors on the screen within the chat window. And that's happened to me, where I'll do that and I can say, are you sure that this line looks right? I think you made a mistake there. And ChatGPT will correct itself. Doesn't always correct itself in the best way, right? Sometimes I found that the corrections themselves have errors, right? But yeah, I mean, you're just going to have to sit there and kind of develop an eye for it, develop the skill for it. In other cases, you might just want to do projects on your own too, Rex, right? Not everything has to start with ChatGPT. I recommend that because that's what the future is going to be. But if you're still saying, hey, I'm at a base level of development, then go ahead and start writing your own code from scratch. And that in itself will also help you develop that eye, right? That ability to read other people's code, ChatGPT's code, and be able to detect when things are wrong. Okay, so I hope that helps you. Explore the Beauty of Nature says, this is a good question. This may not be directly related to our current study. When presenting your results, should you include a detailed research publication style workflow? This would involve extensive literature, etc. I'm going to assume that you mean to the business, right? Or who are you saying when you're going to publish it? Or presenting your results. Who do you have in mind when you say presenting your results? Because I'm assuming you mean like your business stakeholders. So explore the beauty. Let me know what is the audience you have in mind? Because it can be audience dependent, the answer to your question. Let me know what audience you have in mind when you say that, okay? No, after the update, they let us use 4.0 mini model for free. Are you sure that's not throttled, Hamad? I mean, you may very well be right, but my understanding is that that's still throttled. Like there's still a time limit on there, okay? If you understand the code, you are good to be an editor. Maybe. It makes you faster if you know code already, right? But yeah, I agree with that. Hamad says, explore the beauty, does not agree with you. Stakeholder wants results that were not literature review presenting findings of PT. Hamad, you're partially correct. And that's why I asked explore the beauty to clarify, because he could be talking about other audiences where you would want to do a broader review, right? So it depends. It depends on the audience, right? Remember, as data scientists, we gotta clarify, right? In fact, Hamad, I think we had this discussion in Discord, right? You guys hear me use the term validate your assumptions, right? So that was me validating my assumptions. In some cases, Hamad is correct, but I think it depends on the audience. So let's see. So explore the beauty is going to clarify. Yes to the business stakeholders. So yeah, to the business stakeholders, you want to basically you want to limit the math, data science, the code, all that. So you just want to kind of give them the bottom line. Here's what we're good at. Here's what we're not good at with the algorithm that we made, right? If they ask further than that, you can tell them how many experiments you ran, what the results of those individual experiments was. In other words, how you got to the answer, not necessarily the technicals of the answer, right? Like the rationale more than anything else, right? The times when you do want to show a little bit more of that literature or a little bit more of that workflow might be like a model review team, right? So remember, guys, I make the assumption that the majority of us are going to end up working in large corporate environments, right? Most data scientists are employed in some sort of corporate enterprise environment, right? I mean, yes, there's government applications and research labs, but the majority of us are going to go work for like some, big corporate entity, right? And in those entities, you're going to have model review teams, right? Where they're going to review your algorithm and your process. So for those audiences, explore the beauty, you would want to do a little bit more of a just slightly more academic presentation, right? Of, the literature, the supporting documents, the supporting API documentation, how you derive your champion model process. That you're going to want to have more, right? But for the business stakeholder side, it's more about the results, right? Here's the number of experiments we ran. Here's what we think it's going to do for your business. Here are the different errors we could be making. What would you like for us to do? How would you like for us to proceed? That's really all they need. Because again, you could have done those experiments with monkeys. They don't care. They just care that you have a solution for them, right? So I hope that helped. I created a whole new website from scratch with ChatGPT. Good for you, Ravindran. ChatGPT is just an amazing product. Rex says, this reminds me of the conversation we had about developing business acumen. Yes, absolutely. Absolutely, it's related to that. Business acumen so we can communicate better with stakeholders. Yeah, Rex, that's exactly right. And Rex is referring to conversations that we are having in the Discord. Let me bring that up. So this is our Discord channel for today. For Data Science with Dennis. We have 67 members in the Discord. So feel free to join us. And Rex is right. We are having various conversations. We're having memes. I think Hamad included a meme yesterday, which is hilarious. So yeah, we are definitely having those different conversations. And you are right. You are correct, Rex. It is similar to that business acumen that we talked about. What was the screen I had up before? Yeah, I think I had that up before. But you are welcome to join us in the Discord for that. It pays to take extra business courses, extra communication courses in your studies, right? Because you are going to have to present those results, and being able to talk to the business is what separates you from other data scientists, other people on your teams. We've had questions about leadership. I think that good communication is what moves you up into leadership, right? If you're able to talk to the business and talk to them in plain language, well, guess what? When they have project ideas or they have needs in the future, you're going to be the one they come to first, because you're the one who speaks English on the team, right? You're not the tech speak guy. Now you're talking to them in a way that they understand. So in turn, they're going to come to you in the future, right? So lots of value in being able to understand the business side and be able to talk with them, right? as an illustration, I can think of a time, well, there's been many times in my career where somebody approaches me and says, I like coming to you because you talk to me in plain words. But I'm thinking about an instance, shoot, I just realized I can't tell you about the exact example, but I was working for a client, a large company, and it was a case where somebody approached me and said, I was leading one of their data science teams, and they approached me and said, "Hey, I think we have a customer service issue with topic X." I can't say what topic X is. "We have a customer service issue with topic X. Is there anything you can do to help us?" And we were able to create an algorithm for them that helped them identify different instances where event X could happen. And we were able to analyze, how many times it had happened versus times where it could have happened but didn't happen, so on and so forth. And then we gave them those results, and those results ended up being worked out into a significant policy change within the company, right? Or an examination of those policies. But those are the times, you're going to have those times in your career where people are going to feel comfortable approaching you. And then in turn, you're going to develop this great project that you already know the business needs because they just spoke to you and say, "Hey, I think we have a problem here. Can you help us? Because, you're our main guy. You're the guy we talk to. You're the guy that we know communicates well. So we're going to come to you first," right? They don't go and talk to the math nerds first, right? Because they don't understand those guys, right? So I think, Rex, you're definitely hitting upon an important part of it, where having that business knowledge is going to help you guys in your career. So thanks for bringing that up, Rex. Hamad says, ChatGPT can do wonders if you know how to use it. Yeah, absolutely, Hamad. That's very true. Joseph says, thanks for explaining how we effectively communicate to stakeholders. Yeah, I think it's an important part, guys. It's an important part of, not just data science, but your overall career development. So definitely encourage you guys to look into books on emotional intelligence, or maybe if you're still in college, you would take courses on like interpersonal communication. I took a course in interpersonal communication in college that I really enjoyed. But you want to look at those types of things. Rex, thank you so much. Rex is providing the link to the Discord there. So if anybody wants to go to the Discord, again, we're having some great conversations, great knowledge being spread there. And it's a good way for you guys to kind of keep in touch after this is all done. All right. Okay, guys. Well, I'm glad we had that discussion on the confusion matrices. I think that's super valuable. So, where can you guys go with this? I want to leave you guys with some self-study, right? What about leave one out cross-validation? Excuse me. We haven't gone over that. Can you write code or leave one out? Or, excuse me, let me say that another way. Can you get ChatGPT to write code for leave one out? I bet it could. Okay, so you do that. What does that confusion matrix look like? Do you think it would be better or worse than the confusion matrix that we saw from, the K-folds validation? It's kind of hard to beat our error rate, right? We got four wrong out of 150, right? So on probability alone, you would say, no, it's not going to be better, right? But maybe it can. There's advantages and disadvantages to leave one out. So I'm going to challenge you guys to go out and do that. Work with ChatGPT in the same manner we've done today. We only gave it a handful of prompts today, guys, right? We only used not even 10 prompts today. So build on that and go do leave one out. What does that look like, right? Okay, guys, but I think I covered everything I wanted to do with today's lesson. Thank you so much. A lot of really good feedback. I really enjoyed this. I'm willing to do questions now if you guys have questions, whether it relates to this study or not, because I know I might have skipped some in the chat, but maybe some of those people are still in the chat or maybe they're not. But I know we're already past 2 hours. So thank you all for hanging in there with me. A couple of you have been here the whole session, which is amazing. Kudos to you guys. So I'm open for questions. Again, if you posted something before, go ahead and repost it in the chat so that I can see it again. But Questions on the lesson, questions on anything else, this is the time for it. But I think this is such a pivotal chapter. I hope that you guys are starting to see, those building blocks, those fundamentals of data science. Like you're always going to be doing this, right? You're always going to be, where's my data? Try it against my model. What did it tell me? That is data science. Like that's what we're supposed to be doing. So give you guys a minute here for questions. Okay, explore the beauty. Oh, you know what? Let me go to a bigger view. So explore the beauty says, could you please recommend some books on business problems solving for programmers? Explore the beauty, I don't think there's a lot of good ones for them. That's one of the reasons I wrote my book, Your First Year in Data Science, to kind of help you start to make that transition into a team. Because look, another part of business, of moving into the business, and I'm telling you guys, you're going to be employed by corporate entities, is how do you work within a data science team? Most study is just done on your own, but now you're going to be a bigger part of a team, right? So I cover that in my book. I try to kind of address that, your first year in data science. So you're going to find some help there, explore the beauty. But as far as business problems for programmers or like use cases, I can't recommend one because I've never needed one. But I really don't know if there's a good one out there. I'm guessing there is. But I can't recommend one because I can't speak intelligently on it. So I don't want to give you bad advice. So sorry. But it's good that you're at least thinking about it though. But work on the communication side, right? There's plenty of communication books out there. Okay. Hamad says thank you very much and learned a lot. Thank you, Hamad. Appreciate you being here, and appreciate your support of the Discord. Also, I know you're in Discord quite a bit. Mohammed Mesalmani says, do you think Masters in University of Texas at Austin, the online program data science, is worth investing in? I don't know that program in particular, Mohammed. So I really can't comment. I mean, I've been to that university. I've been part of the career fairs at that university, so I know it's a very good university. But I can't comment on their particular program. Sorry. I don't like to speak on things I don't know about. So I wish I knew more about individual programs, but I do not. So, yeah, I mean, I couldn't advise you. Alan says, I'm actually confused about what we would gain from using leave one out, and furthermore, why should we accept the k-fold validation as our final answer? Well, I think you're hitting on a very important point there with leave one out. What are we doing when we try leave one out? Like on a meta level, right? What are we doing there? And that's open to anybody in the chat, right? What are we doing when we're going to say, let me go to leave one out? I'll give you guys a hint. It begins with the letter E. What do you guys think? What are we doing there? Give you guys another second to think about it. There we go. That's right, Alan. It's an experiment. You're suggesting another experiment, and that's a good thing. You want to experiment, right? That's a positive thing of data science, right? So yeah, we're experimenting. You should always be looking to experiment, right? Now, having said that, when you say what would we gain from using leave one out, maybe you wouldn't. And that's going to be driven by any number of factors that are not always under your control. Maybe there's a business deadline. Maybe there's a lack of GPU resources. Maybe the business says, yeah, that's good enough. Or think about the opposite of that, right? As Yassine correctly pointed out, we had 4 errors out of 150 instances. Is that a good error rate for loan decisions? Yeah. Is that a good error rate for a self-driving car deciding when to press the brakes or not? Maybe not so much, right? So it just depends. Maybe it's a good error rate, maybe it's not. Right? We went through that in that same exercise in a previous class, right? Where we saw a confusion matrix and everybody agreed that it was good for loans, but because it had a 85% accuracy, I think is what it was. But then we reframed the problem into, what if this was a self-driving car and decisions for a self-driving car? Do you want a self-driving car to fail 15% of the time? Probably not. So it depends, Alan. There is no individual answer, right? Every data problem is different. Every model is different. Every experiment is different. So yeah, sometimes it makes sense to continue. Other times it won't. Other times you will be told to stop. Other times you will be told to continue, right? The business will tell you to continue. So it just depends. Just depends, okay? Joseph says, thanks for clearly defining k-fold and cross-validation is really helpful. Yeah, you're welcome. And I'm glad you say that, because I think there is a lot of confusion out there between them, right? Cross-validation is learning. K-folds is just how you're selecting a different way to select the samples, right? But 85% of the time when I've asked that question, what is cross-validation? The applicant, the person I'm interviewing, tells me the definition for k-folds. Right? So please don't make that mistake. If you don't make that mistake, you'll be standing out among candidates, I guarantee it. Any advice to switch to big tech like Meta and Google? No advice in particular, right? I mean, to me, it doesn't make sense to limit your company choices like that, There are, believe it or not, guys, there are more companies on the planet than Meta and Google. I promise you, there are more companies than 2, okay? Yassine says, can you please provide a general idea about the technologies we might need to do data science professional environment and deploy models correctly? Thank you for your efforts. Yeah. Your first year in data science? That's basically what I talk about, right? What is that shift that you need to make from school to a professional environment, right? Academic programs don't teach you how to go after your own data. They don't teach you how to talk to stakeholders. They don't teach you how to deploy an algorithm and how to maintain it, right? Academic programs are terrible at all of those, right? So that's what I recommend. And really, it's not, looking at your question, it's really not about the individual technologies, Yassine, because a lot of those technology stacks will be decided for you based on where you work, right? Like, they're not going to change your technology stack just because you're coming in and don't know it. You're going to have to adjust to them, right? So that's what I would advise you to think about, You have to be flexible to where you're going to end up and what stacks that they end up working with, right? All right, last call for questions, guys. We're hitting on 2 hours, 20 minutes. Good job, guys. Anybody else? Last call for questions, or you can also catch me in the Discord. I believe Rex just also posted that Discord link as a reminder, so thank you for that, Rex. Yeah, and by the way, guys, shout out to Joseph and Rex for helping me with the mod. Make sure you thank them next time you see them. They're doing a really good job with that. Yassine says thank you. So yeah, I hope it helped, Yassine. All right, guys. So I think this is a good time to wrap it up. I really appreciate all of you being here. Come back next week, Chapter 6. I gotta be honest, I don't even know what Chapter 6 is. I only look ahead a couple days ahead of time. But yeah, whatever Chapter 6 is, we're gonna be covering it next week. So look forward to seeing you there. I also stream every day at 1500 GMT, so come join for that. Yesterday we had a great session. We had a little game show. Just to have a little break in the content and all that. But tomorrow we're back at it. Oh, and by the way, tomorrow I am releasing a video for the first time where I talk about how I made the mid-career transition from software development into data science? People have asked me that question. I've never done a full video on it. I've shared little bits and pieces, but this is the first time I'm sharing the full video. So that's being released tomorrow. Look for that on my YouTube channel, Data Science with Dennis. But thank you so much. Appreciate the questions, appreciate the participation. Take care of yourselves, take care of your families, and I'll see you next time.